So you've got a force sensor down here measuring the impact of the ball as it bounces on that surface. The ball's got a mass of 0.05 kilograms, so that's your first piece of information. It's dropped from rest, so its initial speed is 0 and height there is 1.6 meters. The graph shows how the force on the ball varies with time during the impact. Show by calculation that the magnitude of the impulse on the ball is 0.35 Newton seconds. So the easiest way to figure out impulse here is to calculate the area under the graph. So you've got two different triangles there. You've got, say, triangle 1 and triangle 2. If you calculate the full area under that graph, then you can figure out impulse from there. So part A, you should find the area of triangle 1 is 0.28. That comes from a half base times height, so it's a half multiplied by 8 milliseconds, so you need to multiply these out. And then the height is 70 newtons. So that comes from that. The area of triangle 2 is obviously going to be a little bit less, that's 2 milliseconds. So that's basically a half multiplied by 2 times 10 to the negative 3 multiplied by 70 gives 0.07. And the total area will be equal to your impulse. So that's 0.28 plus 0.07 gives you 0.35 Newton seconds. So anytime you've got a force time graph given in an impulse question, just go straight ahead and figure out the area underneath the graph. That's the easiest way to do it, rather than to think about calculating how fast this might be going when it hits the ground. Part 2. What is the magnitude and direction of the change in momentum of the ball? Well, impulse is equal to change in momentum. That's what the Ft equals mv minus mu says. That's what that equation means. You've already figured out what the impulse is. It's 0.35 Newton seconds. So your change in momentum is 0.35, but change in momentum, remember the units are kilogram meters per second. And you've got to think about which direction the change in momentum is. Well, the ball is dropped down here and then it's going to rebound upwards, so its change in momentum is upwards.
Could you put negative?
As long as you gave a correct direction.
So you can use just the negative?
No, because it says state the direction there. If you put negative 0.35 and said opposite direction or something like that, then that would be okay. Part 3. The ball is travelling at 5 meters per second just before it hits the force sensor, so that's your initial speed, that's u. So this is u, 5.6 meters per second. Calculate the speed of the ball just as it leaves the force sensor. Well, impulse, as we've written up there, is equal to change in momentum, which means Ft is mv minus mu. So that's 0.35 for impulse equals your mass of 0.05 kilograms multiplied by v, which you don't know. V is going to be in the opposite direction to u, so you could make v negative, or you could make, it's probably just as easy to make u negative here, so it's 0.05 multiplied by negative 5.6. But again, it doesn't matter which one you make negative as long as you make one of them negative to show that it's in the opposite direction. So that gives you basically a positive number here because you're minus that number. Solve for v and you should get 1.4 meters per second. If you put u in as positive, then that would come out as negative. You know, it doesn't really matter. That would that would be an acceptable answer, as long as it shows that you understand the difference in direction, that you understand it's in the opposite direction from where it was going initially. The last part there, another ball of identical size and mass, so same size, same mass, but made of a harder material, is dropped from rest from the same height onto the same force sensor. You know, it's one of those typical questions on the end there where one thing has changed and everything else is kept the same, and you've got to try and figure out how that affects the results that you would get. So sketch the force time graph that's shown there, so this one that we've got here. So I'll just scrub this stuff out and I'll draw my graph on top of that. Sketch the force time graph. Numerical values not required, but you should label the axis clearly. So in this case you would just copy this down exactly as it is, and you would draw the force time graph for the one that has a harder material. So you should be thinking harder material, okay, what's going to happen with a harder material? Harder material is going to have a greater force, but it's also going to rebound quicker. You know, because it's got a larger force, it must therefore have a smaller time of contact. Because this change in momentum is the same, the mass is the same as before, it's dropped from the same height, so it's going to be, you know, it's going to have the same change in momentum, the same change in speed. So if this force is going up and this is the same, then the time of contact must go down. So you're looking to draw in here something that is bigger in force but has a shorter time of contact. It doesn't necessarily matter where you end up with your force finishing here, it doesn't really matter there, they're not interested in numerical values, just interested in the fact that you can understand that a harder material will cause a greater force, and because the change in momentum is the same, therefore the time of contact has to be less.